it different from a PROM and a PLA? In a PROM, we have AND gates. That means a decoder generates all the possible minterms, and then followed by an OR gate, which are programmable. So PROM has fixed AND gates and programmable OR gates. Whereas in PLA, we have both programmable AND gates and programmable OR gates. So it is more flexible. But as compared to PLA, your PAL, it is less flexible. So PAL means programmable array logic, where your AND gates are programmable, whereas your OR gates are fixed. That is what is there in a PAL. If you want to remember it, just we can make one table. PROM, PAL, PLA. What about AND gates? Fixed, programmable, and programmable. And what about OR gates? They are programmable, in this it is fixed, and in this it is. So in PAL, your AND gates are programmable and your OR gates are fixed. One more thing which is different from PLA and PROM is, in this will not have a decoder and will not generate the complement of the functions in SOP form. We'll have just the expressions. Let's have a function f1 which is dependent upon the variables a, b, c, and this function is the function, and we have to implement two functions using a PAL. Now in a PAL, you can your AND gates, they are programmable, but OR gates are fixed. We are having an OR gate which has 3 inputs. All the OR gates will have 3 inputs. Okay? But you can have any number of OR gates, but all the OR gates will have 3 inputs minimum. Okay? So OR gate input is fixed. So first task is to find out the expressions in SOP form and its true form, not any other form. This is a restriction here. You can't use a decoder, first thing, because if it is a decoder, it will become a PROM. Second thing is, AND gates are programmable, but you cannot find its complement in SOP form. So you have just a position that you can have it in its true form. So let's have F1 in its true form. 1, 2, 4, 5 and 7. What do you get? One. So you get A, B, 1. Then you get 2. A, C. Then you get 3. B bar C. And this is alone, you cannot club it with anybody. A bar B C. So we have 4 inputs, 4 product input, 2, 3, 4, whereas we have a provision of an OR gate with just 3 inputs. We'll have an OR gate and you'll have just 3 inputs. So an OR gate has 3 inputs. This is a restriction. This is a fixed OR gates we are having. If you have F2, zero, 1, 2, 3, 4, 5, 6, 7. So what do you get? You will get, this is one quad. So what do you get? A changes, B changes C. And this is one pair. A bar, B bar. Here F2 has 2 terms and here F1 has 4 product terms. So, but to get F1 we have 3 inputs. It can only take 3 product terms to get F1. What about the 4th one? So what we do is, we'll have another expression which will have 2 product terms. So therefore we can write your F1 as F3 plus B bar C plus A bar B C bar. Or I can write it here. So F1 just reduces to F3 plus B bar C plus A bar B C bar. That means we have to get 3 functions, F1, F2 and F3. The majority functions are F1 and F2, and F3 has to be found out for implementing F1. So next task is to make a PAL table. So what is the PAL table? You will have the product terms, then the inputs A, B and C, and then the outputs F1, F2 and F3. What are the product terms for this? You will have C, this is first product term, A bar, B bar. C is 1, A bar, B bar. So it is in F2. What is F1? Then you have F3, A, B bar, A, C. B bar, C, A bar, B, C bar. So A, B bar, A, C, sorry, it's not present, so it should be dash. B bar, C, A bar, B bar, C bar. And these are all present in F1. So we will not have F2 because we have only 2 outputs. So this is the PAL table, you have to make it. Then is its implementation. So how do you do the implementation of this? So what you have is, you have programmable AND. How do I draw it? It will take more space. Let me draw it. A bar, B, B bar, C, C bar, this will be C. A bar B bar. Then A B bar. Then A C. Then B bar C. Then A bar B C bar. So I have generated all the terms. Then what is F1? It is F3. That means I have to have F3 also. Okay. First generate F3. What is F3? AB bar. Let me have F3. What is F3? AB bar plus AC. But it has three inputs. Your OR gate has, the condition is that OR gates are fixed and DOR gates have three inputs. So we cannot leave the third input as open. So you should make it 0 so that F3 is AB bar plus AC. F3 is AB bar plus AC. So what you do is you will have another AND gate which will give you 0. This is basically all the fuses are intact. All the fuses are intact. So what you will get AA bar, BB bar, CC bar. That means it will be equal to 0. So you have three inputs connected. What is F2? C plus AB bar. A bar, B bar. So C and A. Again, the third input. So you can connect it to 0. So if it is a fusible contact, all fusible, then the output for an AND gate will be 0 and for an OR gate it will be 1. And then next is F1. What is F1? F3 plus B bar C plus A bar B C bar. So what you have? B bar C as one input, A bar B C bar as second input, and what is this? One more input is F3. So what you do is your F3 goes in here. This is F3. And there is one more AND gate. I can draw it here. is giving you F3 rather than this. This is F3. So what is this? This is F3. It is going as an input to one of the gates, and it is giving a F3. So what is this? Is F3. And where is F3 used? Here. So actually what we are doing here is we are having a function and we want to implement it using a PAL. We have programmable and in that we can just have functions in their true form. When you have functions in their true form, you have a restriction on the number of inputs of a OR gate. That means their inputs are fixed. So we have inputs with 3 OR gates. So here when you analyze this, you get a minimized expression for F1 and F2, where F1 has 4 product terms, F2 has 2 product terms. If the product terms are less, then they can be easily implemented by making one of the inputs 0 for an OR gate. But if they are more, then how to implement that using a OR gate? What you do is, you use a part of this expression as a third output. So your function becomes sum of 3 product terms, F3, this and this. So when you have this, you can generate F3, which is a sum of 2 product terms, and you can simply take that output as an input, and you can get the F1 and F2. So here again this gate has 3 product terms as the inputs. So one of the product terms will be 0. This AND gate is actually generating 0. It is AA bar, BB bar, CC bar, all C. So this is all about your PAL table. So what we have done till now, I can implement this function using PAL also. I can implement this function using PLA also. I can implement this function using PROM also. So let's take the same problem and implement it using a PLA. So this was PAL. Let me implement using PLA. Let me complete this. This was F1 and true. F1 in its complement form will be written as F1 in its complement form will be A bar, B bar, C bar, A bar, B, C, A, B, C bar. And F2 is in complement form will be so A bar, A, B bar, C bar plus this is one, sorry, this is another. So I get BC bar plus A or B changes C bar. This is what we get. So if you make the combinations F1 in true form and F2 in true form, how many product terms? 7. F1 in true form, F2 in complement form. 6. F1 in complement form, F2 in true form. 8. F1 in complement, F1 in complement form and F2 in true form. 5. F1 in true form and F2 in complement form. 6. F1 and F2 in, this is also 6. And F1 in complement form, F2 in complement form. F1 in complement form and F2 in complement form. So it is again 5. So you can use any of these two combinations to implement the PLA table. So what is the PLA table here? It is F1 in complement form. ठीक है, तो क्या होगी F1 की A bar B bar C bar, A bar B bar C bar, A bar B C and A B C bar, ये product terms है F1 in complement form. और F2 in true form, so here F1 is in complement form, F2 is in true form. And how do you make this table? 0, 0, 0. So 0, 0, 0, 1, 1, 1, 0. C, A bar, B bar. So this is how you make a PLA table. And the circuit, simple. You will generate the product terms A bar, B bar, C bar. This is the circuit. A bar, B, C. This is the circuit of the same function but by a PLA. I'll get F1 complement. And then you will have a XOR gate with 0 and an XOR gate with 1. F2 will be fed to this. And F1 will be complemented with this F1 bar. Fine. What is ABC? So this is C bar, C, just C. This is C bar, C, C bar. also B, this is also B, this is B bar. Then you have A bar, PLA implementation of a function where you will see that you have lesser number of circuit. So what you have? A bar, B bar, C bar, A bar, B, C, A, B, C bar, C, and A bar. This is a same function, but we are implementing using a PLA. Next is, what we can do is, we can implement it using a ROM also. PROM, programmable read-only memory, where you cannot write anything. Data is stored in the memory. These are all combinational PLDs. You can have sequential PLDs also. So in a PROM, we are storing the data and we are reading the data. Nothing else, no more options. So there is, when you are having a PROM implementation of the given function, what do you do then? You will have a decoder. Since there are 3 inputs, you will have a 3:8 decoder. So that means AND gates are fixed. There are 3 inputs, 3 variables, 3 inputs. And there are 2 functions, so there will be 2 OR gates. There is no need of minimization. So we'll have 1 and have 2. Only OR gates are programmable. So 1, 2, 4, 5, 7. And 0, 1, 3, 5, 7. So this is what is a implementation of the same function using PROM. That means fixed AND gates and programmable OR gates. This is what is the whole scene. How do you do it? So that's all for today. Thank you.